Welcome to exercise 10.3 of chapter 10 mensuration. In 10.1 we discussed the perimeter based questions of square and rectangle and equilateral triangle and all related to perimeter. 10.2 is a very small exercise in which you have to find the area by counting the number of squares in the shape. That I think you can do by yourself because you already learned that in smaller classes. Now we are on to the last exercise of this chapter, that is 10.3. So let us move on to the question number 1. Find the areas of the rectangles whose sides are A 3 centimeter and 4 centimeter. So let us see. So area of a rectangle is what? First you have to write the formula. Always write the formula first. So area of a rectangle is length into breadth, that is L into B. So length is 3 centimeter, breadth is 4 centimeter. So what's the area? Area equal to length into breadth, that is 3 into 4, which is equal to 12 square centimeter. That's the unit. Then B. What is the question? Area of the rectangle L into B, and here length is 12 meter and breadth is 21 meter. So the area is 12 into 21, that is 252 square meter. Now question C. Again area of the rectangle L into B, length is 2 kilometer and breadth is 3 kilometer and the area is 6 square kilometer. And the last one, it is the length and breadth are 2 meter and 70 centimeter. So you have to convert them into same unit. Either you have to convert 2 meter to centimeter or 70 centimeter to meter. So meter to centimeter is more convenient. So you have to multiply meter with 100 to convert it into centimeter. So 2 meter is what? 200 centimeter. Then breadth is 70 centimeter. So what's the area? It is 200 into 70, 14,000 square centimeters. So this you have to be very clearly, you should know that unit must be same. Don't multiply 2 into 70. So please look, make them into the equal same unit and then you have to find the area or perimeter, whatever it is. Okay. Now let us move on to question number 2. Find the areas of the squares. Square is very easy, no? Square, all the sides are equal. So if you know the one side, what's the area? Side into side. Or I can say A into A. If I give A for the side, A into A I can say. So if side is 10 centimeter, so area is 10 into 10, 100 square centimeter. And the second one, its side is 14 centimeter. So the area is 14 into 14, 196 square centimeter. And the third one, the area is side into side. It is 5 meter. So 5 into 5, 25 square meter. Very easy one, simple one. Let us move on to question number 3. The length and breadth of 3 rectangles are as given below. 3 rectangles measure length and breadth is given. Which one has the largest area and which one has the smallest area? So we have to find the area of all these 3 rectangles. So let us first find the area of the first rectangle, which is equal to length into breadth. Length and breadth is given. So the area is 54, 9 into 6, 54 square meter. Then B, the length and breadth are 17 meter and 3 meter. And the area is 17 into 3, 51 square meter. And the third one, area, the length and breadth are 4 meter and 14 meter. And the area is 56 square meter. So which rectangle has the largest area? Yes. And the smallest one is? Yes, that's the smallest one. Clear? Now move on to question number 4. The area of the rectangular garden 50 meter long is 300 square meter. Find the width of the garden. So what is given here? Area is given, length is given. We need to find the width. Width means breadth. We have to find that. So let this be the garden, and length is given 50 meter, and width or breadth that is not given, that we have to find out. But to find that, what is given? Area is given. Area of a rectangle is what? Yes, L into B. L into B is 300. So what is length? Length is given 50 meters. So width will be what? Area divided by length. Yes, area divided by length. So which is equal to 300 by 50, which is equal to 6 meter. So the width of the garden is 6 meter. So when area given and length or breadth, any one of them given, to find the other, what you have to do? You have to divide area divided by length or breadth. Okay. Next one. What is the cost of tiling a rectangular plot of land 500 meter long and 200 meter wide at the rate of rupees 8 per 100 square meter? So tiling means, you know what is tiling, is it? So suppose this is a rectangular plot of land and the tiling, put the tile there inside that. So that means we need to find what? We need to find the area. We need to find the area of the plot. So first the area of the plot, let us find out, which is equal to how much? How many zeros are there? Okay, 1, 2, 3, 4, 5 zeros are there. So it's 1 lakh square meter. 1 lakh square meter. And what we have to find? The cost of tiling at the rate of rupees 8 per 100 square meter. That means for 100 square meter you have to pay 8. So in this 1 lakh square meter, how many hundreds are there? That we have to find first. Then only we can multiply that with 8, is it? So cost of tiling for 100 square meter is rupees 8. So what is the cost of tiling for 1 square meter? If many is given and you have to find one, what you do, children? You have to divide. So it is 8 by 100. So what is the cost of tiling for 1 lakh square meter? 1 is given and to many. So you have to multiply. That means 8 by 100 into 1 lakh, 0 you can cut. So what we will get? 8,000 rupees. Next question. A tabletop measures 2 meter by 1 meter 50 centimeter. What is the area in square meter? We have to find the area in square meter. So suppose this is the tabletop, 2 meter and 1 meter 50 centimeter. L into B is the area. Length is 2 meter. What is the breadth? 1 meter 50 centimeter, which we have to convert into meter. How we will convert centimeter to meter? 1 meter remains 1 meter. 50 centimeter will become what? 0.50 meter. We have to divide by 100, is it? So it will become 1.50 meter. Now the area 2 into 1.5. How will you multiply the decimal? You have to multiply 15 into 2. 15 into 2, what you will get? You will get 30. Now how many decimal places are there total here? Only one decimal place, is it? So one decimal place should be there in the answer also. So 30, one decimal place you put that 3.0 it will become. So the area is 0.0, no need to put. So it is 3 square meter is the area of the tabletop. Clear? Now moving on to question number 7. A room is 4 meter long and 3 meter 50 centimeter wide. How many square meters of carpet is needed to cover the floor of the room? So entire floor you have to cover with the carpet, is it? So let this be the floor. 4 meter is the length, 3 meter 50 centimeter is the width of the room, and we have to put a carpet there. Okay, a carpet. So we need to find the how many square meter. What is the area of the carpet? Means area of the floor, because it's fully covered. No. So area of the carpet equal to area of the floor. So length of the room is 4 meter and breadth is 3 meter 50 centimeter. So we have to convert that into either centimeter or meter. But the question is how many square meter is asked. That means we have to convert this into meter. So 3 meter 50 centimeter is how many meter? 3.5 meter. Now we have to find the area. L into B, 4 into 3.5. As I told you earlier, 3.5 into 4 means you multiply 35 into 4. 35 into 4 you multiply, and in the answer put one decimal place. So 35 into 4 you will get 140. So one decimal place, so 14.0 will come. 0.0 no need to write. So 14 square meter is the area of the carpet. Clear? Next, question number 8. A floor is 5 meter long and 4 meter wide. A square carpet of side 3 meter is laid on the floor. So in this case, it is not like the previous question. It's not covering the entire room. A part of the room only covered. Is it? Find the area of the floor that is not carpeted. So this is the floor of length and breadth for 5 meter and 4 meter. And what is the size of the carpet? It's a square carpet of all the side 3 meter. So let this be the carpet of side 3 meter. So you can see some area which is not carpeted. That area we have to find. So how we will find that? Think. What you have to do? What do you have to do? Yes, you have to find the area of the floor, that minus area of the carpet. Then you will get the remaining part, or the area of the floor which is not carpeted. Is it? Okay, then let us do. Area of the floor not carpeted is equal to area of the floor minus area of the carpet. So we know the length and breadth of the room, not room, the floor. So we can find the area of the floor, which is equal to 5 into 4, 20 square meter. Now area of the carpet, it is a square, is it? Or the side equal, so side into side. So 3 into 3, 9 square meter. Now what we have to do? We have to find the difference. We have to subtract. So area of the floor not carpeted is equal to 20 minus 9, which gives you 11 square meter. That's the area which is not carpeted, which is not covered by the carpet. Is it clear? Yes. Now move on to question number 9. 5 square flower beds, each of sides 1 meter, are dug on a piece of land 5 meter long and 4 meter wide. What is the area of the remaining part of the land? So let this be the piece of land 5 meter long, and all other questions also 5 meter 4 meter. Is it? Repeating that is it? Okay. 5 meter 4 meter, that's the length and breadth. And what is done there? 5 square flower beds are dug on the land. Okay. So let this be the 5. All are having 1 meter, all the side 1 meter square. What we have to find? What's the area of the remaining part of the land? So what you have to find? What you have to do? Yes, first you have to find the area of the total, that piece of land that you have to find. Then you have to find the area of each of the square beds. Then you have to subtract them. Is it? But here all the square flower beds are of equal size. So instead of finding the 5, you have to find the area of 1 square bed, flower bed, and you have to multiply that with 5. So you will get, because all are same, no? Okay, so let us do. Area of the remaining part of the land equal to area of land minus area of 5 flower beds. So land, length and breadth given. So we can find the area L into B, which is equal to 20 square meter. Now side of the square bed is 1 meter. So area of 1 square bed, what will be? 1 into 1 square meter. So what will be the area of 5 square beds such? So 5 into 1, 5 square meter. So now what to do? Subtract. Yes, area of the remaining part is 20 minus 5, which is equal to 15 square meter. Very simple and easy question, is it? Very interesting question also. Next, question number 10. By splitting the following figures into rectangles, find their areas. Their measures are given in centimeters. So this is little bit you have to concentrate. You have to observe the figure carefully, how to divide, how to find the unknown sides. Little bit you have to be keen here. Let me tell you that first. So observe carefully. Let us do. First of all, I have to split this into different rectangles or square, whatever it may be. So anyway you can split as per your wish, you can split. So here I am splitting it in this way. Okay, now I splitted. I got 1, 2, 3, 4. I got. Now carefully look, carefully observe. This is 4 centimeter. So what will be this side? That also 4 centimeter. But here it is given the below part is 3, no? This is given as 3. This much is 3. So, what will be that part? Yes, it will be 1. 4 minus 3, 1. Got it? Okay. Now, so opposite that also 1. Clear? Understood? Next, this is 3. So, the opposite side, that also 3. When that also 3 means here it is 2. Is it? So what will be this part? What will be? Yes, 1. That also 1. Now, that is 3. When that is 3, that is also 3. But in that, this portion is 1. So what will be this portion, this small piece, how much it will be? That will be 2. Now this total is 4. So this is 2 means what will be this half? That also will be 2. Clear? Understood? Observe, observe it. Now, what about that? This is 2, no? So this also 2. Now what about this? This is 2, this is 1. So what about this? How much it will be? That is 3. Now we got all, is it? Now this is 2. So what is that? Here this is 2. So here also, that also 2. Okay. Now how many rectangles are there? 1, 2, 3, 4. Now we will find the area of each of the rectangles. So rectangle, area of rectangle 1, 3 into 4, 12 square centimeter. Because 3 into 4. Is it clear? Now, area of rectangle 2, 4 and 1. So 4 into 1, 4 square centimeter. Now, area of rectangle 3, this is 3, this is 2. Observe, observe properly. So 6 centimeter, 3 into 2. And rectangle 4, this is 3, this is 2. So 2 into 3, 6. Now what is the total area? You may have to add all. So 12 plus 4 plus 6 plus 6, which will give you 28 square centimeter. You can split here this way, like that also you can do. So some other ways also you can do it. Okay, whatever way you do, last the answer will be the same. 28 square centimeter you will get. Understood? Now let us move on to the next figure. This is quite easy one. So how can I split them? Yeah, I split like that. So yeah, this is one rectangle, this is the second rectangle, and that is the third rectangle. 3 rectangle I got. Now here, this total length is given as 3. Okay, this total length given as 3. This is given as 2. Observe. So when this is 2, that much is 2. So what will be that part, upper part? That will be 1. Clear? Now this also 2. Okay, now we got all the dimensions. Yes. Now area of rectangle 1. Rectangle 1 area 1 into 2 or 2 into 1. Now rectangle 2, same, 2 into 1 only. Now rectangle 3, here 5, breadth 1. So 5 into 1, 5. So what is the total area? You have to add all. So it is 9 square centimeter. Clear? Next one. Again, split the following shapes into rectangles and find their areas. Measures are given in centimeter. This is also very, very simple one. Just one cut, we can divide it into 2 parts. You can cut here also. Okay, like that also you can partition it. So here, that is the first rectangle, second rectangle. First rectangle area, length is 10. Don't take it 12. 12 is the full length. We took only this much. So don't make the mistake. It is 10. Okay. 10 into 2. Now rectangle 2. It is 10 into 2, not 8. 10 into 2. So the total area will be 20 plus 20 equal to 40 square centimeter. Now next one, next figure. So here we can split like this, easy way. So here 1, 2, 3. 1 and 2 are they rectangle? No, they are squares. Is it? They are squares. And what is that? That one, that part, what's the length? This is 7. No, so this also 7. Is it? That is 7. So what will be this total length? 7 plus 7 plus 7, 21. Now area of rectangle 1, or no, square. It is square or rectangle. So I can say no problem. So it's a square. Yes. So 7 into 7, 49 square centimeter. Rectangle 2, 21 is the length. No, 21 and width 7. So 147. Then rectangle 3, again 7 into 7, 49. So add everything, you will get 245 square centimeter. Okay. Now next figure. Here we can cut like this. So first, second, 2 rectangles. So first rectangle, what is the area? Very, very simple, 5 into 1. And second one, 4 into 1. That's all. So the total area is 5 plus 4 equal to 9 square centimeter. Very easy one. Next question. How many tiles whose length and breadth are 12 centimeter and 5 centimeter respectively will be needed to fit in a rectangular region whose length and breadth are respectively, in the first one 100 centimeter and 140 centimeter, second one 70 centimeter and 36 centimeter. So what is the question? Suppose this is a rectangular region of length and breadth 100 centimeter and 140 centimeter. What I want, suppose this is a tile whose length and breadth are 12 centimeter and 5 centimeter. I want to know how many such tiles can be fitted into this rectangular region like this. Can fill it. That's what I have to find. Is it clear? Understood? So what we have to do? That is area of the rectangle. Area of the rectangle equal to 100 into 144, so 14,400 square centimeter. Now area of one tile is what? 12 into 5. Now what we have to find? How many small tiles can be fitted into that big rectangle? So what you have to do? Number of tiles that can be fit in the rectangle equal to area of rectangle divided by area of one tile. Then only we will know how many 60s are there in this 14,400. Got it? So divide it, 0, 0 cut, divide, you will get 240 tiles can be fitted. Now in the part B, the region is how much? 70 centimeter and 36 centimeter, smaller one. So the same size of this tiles will not fit 240 into this. It's common logic, no. So let us find out. Area of the rectangle, L into B, 70 into 36, 2520 square centimeter, and the area of the tile is same, that is 60 square centimeter. Now number of tiles we have to divide. So 2520 by 60, on simplifying 0, 0 you can cut, on simplifying 42 tiles you can fit into that. Clear? Hope you understood it clearly, is it? Okay, now there is an extra question, a challenge question is there. What is it? Very, very interesting. I love this question very much. On a centimeter squared paper, make as many rectangles as you can such that the area of the rectangle is 16 square centimeter. Consider only natural number length. Which rectangle has the greatest perimeter? Which rectangle has the least perimeter? If you take a rectangle of area 24 square centimeter, what will be your answer? Given any area, is it possible to predict the shape of the rectangle with the greatest perimeter, with the least perimeter? Give example and reason. So let us do it. So centimeter square paper. First 16. If you want to get 16 as the area, we know the area of a rectangle is length into breadth, is it? So here if I take 16 as the length and 1 as the breadth, 16 into 116. Then what other combination where I will get when I multiply two number, I will get 16. Think fast. Yes, 8 into 2. However, nothing else? Yes, 4 into 4. Okay, now let us see. 16 into 1. So 16 into 1, let us find the perimeter, what it will be. Perimeter is 2 into L plus B. So it is 34. 2 into 7, 34. Next is 8 into 2. So 8 into 2. So let us find what will be the perimeter. 2 into L plus B. So 2 into, yes, this is the 32. Now the third one, 4 into 4, 16. So what is the perimeter? 2 into L plus B, or it is square, no? So 4 into side. So perimeter is 16. So in which you have the largest perimeter? The first one, is it? First one. That means when length is more, the perimeter is more. Okay, now let us see the second example, that is 24. Think about how can, in all ways, what all ways we can get 24 as the area. Which two numbers when you multiply, you will get 24. Quickly think about the factors. Yes, 24 into 1, 24. Then fast. Yes, 12 into 2, 24. Next what? 8 into 3, 24. Is over? No. More are there. 6 into 4, 24. Anything else? No. is it? Okay, so if I take 24 into 1, length 24, breadth 1. So can we find the area of that? 2 into L plus B? Yes. What is the perimeter? 50 centimeter. Now the second case, 12 and 2. What is the perimeter? 28. And 8 into 3, then the perimeter is 22, became smaller. And 6 into 4, perimeter became 20. So area all same, but the perimeter are different, is it? So where did you find which perimeter is more? In what type of arrangements you will get the more perimeter? If you arrange lengthwise, is it? If you arrange lengthwise, the perimeter is increasing. When you arrange breadthwise, the perimeter is decreasing. Is it? This you can try with any other number. For example, you think about somewhat bigger, about 30, 36, 50, 100, like that you think. And try to find so you will get so many areas. So with this you will learn not only the area and perimeter, children, you will learn the factors, multiples, what are the factors of number. So all those things you can revise when you do this. One concept you are learning, more thing you are remembering. So try with so many numbers, perimeter. Then you think in other way. Perimeter same the area, what will happen? Same perimeter. You take 20 as a perimeter and you take values length and breadth and see which is having more area. It's quite interesting. Do it, children. Do it. So this chapter is over now. Thank you for watching. Bye.